Okay, so we are going to start today with this quadratics revisit. And I've separated our topics out so that we're covering basically one big idea a day. And it follows pretty well the order that we learned it in the first place. So the first thing that we learned how to do with quadratic functions was graphing them. So that's where we're going to start for today. We're going to graph some parabolas. We're going to graph some quadratic functions. We're going to talk about how changes in the function result in changes on the graph. Stuff that we have already seen. Again, this is not brand new information. We've spent 2 units on this already, but just a revisit, just sort of a refresher on stuff that, again, you are going to need to know how to do for Algebra 2. So the very first thing I want to talk about is the graph of what we call the parent function. So the most basic quadratic function we can have. It's got no bells and whistles. It is just plain old x squared. Okay. The graph of this thing has its vertex right at the origin. And then to find our nice points, we go from the vertex out 1 and up 1 on both sides. We always count from the vertex out 1 and up 1. And then our next set of nice points would be out 2 and up 1, 2, 3, 4. Out 2 and up 4. Remember, we're always counting from the vertex. And the nice thing about parabolas, the nice thing about quadratic graphs is that they're symmetric. So whatever I do on one side, I have that mirror image on the other side. So this is what my graph looks like right here. Okay, our vertex is at the origin. It's at 0, 0. Our x-intercept, where I cross the x-axis, is also at 0. And my y-intercept, where I cross the y-axis, is at 0. So that's our parent graph. Every quadratic function that we graph is some sort of transformation of this. Is some sort of maybe shifted around, manipulated, stretched, or flipped version of what I have right here. So we're going to talk about some of the things that we can do to the equation and how that translates to a change in the graph. So the first thing we're going to look at with example 1 and example 2 is what happens if I change that lead coefficient. If I change that A value, how does that change my graph? Okay. So for example 1, I've got a 2 in front of there. Remember that that means that that's going to stretch my graph vertically. Those vertical distances that I travel are going to be multiplied by 2. They're going to be doubled. So my origin stays, or my vertex, I should say, stays at the origin. Our vertex stays exactly where the parent graph vertex is. And then what happens is I go out 1, and then because I have a 2 there, the amount I travel up to get to that next nice point is multiplied by 2. Normally it's out 1, up 1. Now it's going to be out 1, up 2. We double it. We multiply it by 2. And I do the same thing on both sides. Now for my next set of nice points, out 2, normally it's up 4, but it's going to be up 8 since we're multiplying by 2. So always counting from the vertex out 2, and then up 1, 2, 3, 4, 5, 6, 7, 8. We're a little off the graph here. That's okay. Remember, we took that vertical distance and we multiplied it by 2 because of that 2 here. We doubled it. So out 2 and up 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's our parabola. So how have we changed this from the parent graph? Well, it's stretched by 2. Okay, it's taller than our original graph. Or I should say it gets taller faster than our original graph. For example 2, same idea, because we've changed that lead coefficient, that A value, it's going to impact the sort of vertical distance that we're traveling, but this time it's a half. Okay, so that means we're going to cut that vertical distance in half. My vertex is still at the origin. Okay, haven't moved that. I'm going to go out 1, but this time, instead of going up 1, I'm going to cut that distance in half, and I'm only going to go up a half. So out 1, up a half. And then for my next set of nice points, I'm going to go out 2, and normally I would go up 4, but I'm going to cut that in half, and I'm only going to go up 2. So out 2, up 2. I've cut that vertical distance in half. So we get a parabola that's a little kind of smashed down. The term I used in Unit 8 when we talked about this was compress. So I'm going to use that here as well. What's the change I've made? I've compressed it by a half. So we don't get tall as fast as our parent graph. If I had 3x squared, we would take our normal vertical distance and multiply it by 3. If I had 1/8 x squared, I would take that normal up distance I travel, that vertical distance I travel, and I divide it by 8, right? That's what we're doing here. Questions for me so far? This familiar? We're coming back a little bit? Okay, you've seen this before, it should be. Okay, on the next page, we're gonna look at some other changes that we can make. So we looked at what if we change that lead coefficient, what if we change that a value? Now we're gonna look at what if I add or subtract something to my function. So for example 3 and 4, I'm adding or subtracting at the end of my function. For examples 5 and 6, I'm adding or subtracting directly to x. That number that I add or subtract is in parentheses with x, the square on the outside. So we're gonna look at how these impact my function. So when I add or subtract at the end of my function, how's that gonna move us? Yeah, it's gonna move my graph either up or down. And these do exactly what you expect them to. So here we've got x squared plus 2. I wanna say that moves me up 2. It absolutely does. So I'm gonna take my vertex and move it up 2 spots. I have nothing in front here with my lead coefficient telling me to change the shape of my graph. So I'm gonna keep it the same as the parent function. So to find my next set of nice points, I'm gonna go from the vertex, out 1 and up 1 on either side. And then from the vertex, out 2, up 1, 2, 3, 4. And again, that's on either side, 1, 2, 3, 4. The nice thing again about parabolas is if you can figure out what to do on one side, the other side is that mirror image. Okay, so how did we change this from the parent graph? It shifted up 2. So for example 4, I've got x squared minus 3. What change would I expect to see here? I would expect it to go down 3. We're actually going to skip over example 4 for right now, and I want to hop down to example 5. This time, I'm adding directly to x, right? That plus 1 is in parentheses with x with the square on the outside. So instead of moving up or down, we'll move left or right. Yeah, these are the ones that we talked about, kind of do the opposite of what I want them to do, opposite of what I might expect. So since this is x plus 1, I want to say it moves forward 1. But it does the opposite. It's going to move back 1. Okay, so my vertex will scoot back 1. And then again, nothing in front here telling me to change the shape of the graph. So to get my first set of nice points, I'm going to move out 1 and up 1 on either side. And then again, always counting from the vertex, out 2, up 1, 2, 3, 4. So out 2, up 1, 2, 3, 4. So here we've moved to the left 1 unit or 1 spot. Questions for me so far? So we've looked at changing the shape of our graph by stretching or compressing. We've looked at moving up or down, left or right. So on the next page, we'll come back to example 6 in a minute. On the next page, I want to take a look at example 7. For example 7, we've got a few of these transformations combined. That's okay. There is something new in here that we haven't talked about yet today. I've got a negative, not just 2, but -2. What's that negative going to do? It flips our graph. Normally our parabolas open up. This one's going to open down. It's going to look kind of like an umbrella. So I know that negative sign is going to flip my graph. We know that that 2 is going to stretch our graph by 2. And then I know this plus 3 at the end should shift us up 3. Okay, those are all the changes I expect to see based on the function. So I'm going to start by moving my vertex where it belongs. Normally it's at the origin, or I should say for the parent graph, it's at the origin. But this needs to be shifted up 3. 1, 2, 3. We're not moving left or right any, so I can go ahead and place my vertex there. Now, these other changes that I'm going to make, the flip and the stretch, are going to impact the shape of our graph. Again, we said normally our parabola opens up. So to get my next pair of nice points, usually we go out one and up one. But this is flipped. So we're going to go out one and down. And then we're also going to stretch this out. So instead of out one and down one, since we're stretching by 2, out 1 and down 2 on either side. And then for my next set of nice points, out 2, down 8. Normally it's 4, but we're stretching by 2, so I have to double that. So out 2 and down 1, 2, 3, 4, 5, 6, 7, 8. And again, same thing on both sides. So there's our graph. We're shifted up 3, we're flipped, we're stretched by 2. For the last couple of examples, I've given you the graph and asked you to write the function and also identify the vertex. Okay, so here we've taken a function and graphed it several times. Now we're going to do the reverse. So if we hop down to example 9, the first thing I'm going to do is identify my vertex. That'd be right here. So that's at -2, -3. My vertex is at -2, -3. Just picking that point out from the graph. And since I know where the vertex is, I know what the function should look like in vertex form. So that's what I'm going to write here. So I know I would have x plus 2 squared and then -3, right? This tells me I moved my vertex to the left 2 and down 3, which is what I did here. And then the other thing I need to look at is have I changed the shape of the graph? So it opens up. I know it's not flipped, so there's no negative that I need, but I need to check to see, should there be a 2 or a 1/3, or is there some a value that I need to put in front that's not 1? So to check that, I'm going to look at how I get from the vertex to my next nice point. What I expect to get from the vertex to the next nice point is to go out 1 and up 1. But there's no point here. It's down here. I would estimate that that's about a half. But to double check, I'm going to take a look at the next point out. So I know normally I would go out 2, up 4, 1, 2, 3, 4, but there's no point here. Instead, it's out 2 and up 2. So that tells me I've cut that distance in half for sure. So I want a 1/2 in front here. I always have to check the shape of that graph. Questions for me so far? Okay, I would like you to go back and try the examples that we skipped. So there are 2 on page 2 and 2 on page 3 that I would like you to go back and try now. Go through the examples that we skipped. Okay, let's take a look at these. For example, 4, I've got -3 at the end. We said that should shift everything down 3. I'm going to move it down 3 spots. So I'm going to move my vertex 1, 2, 3 spots down. And then nothing else about this should change. It has the same shape. So out 1, up 1 on either side. And then out 2, up 1, 2, 3, 4. There's our parabola. So we went down 3. Not too bad? Okay. For example 6, I've got x minus 2 squared. So again, this is going to do kind of the opposite of what I want it to. I would sort of expect it to go back 2 units, but it's going to do the opposite. It's going to go forward 2. And then same shape as our parent graph. So out 1, up 1 on either side. Out 2, up 1, 2, 3, 4 on either side. So there's our graph, and we have moved to the right 2 places. Questions for me on 4 or 6? Okay. On page 3, example 8 has a couple of changes here. I've got a +2 here, so this is going to move me to the left 2 spots. I've got a -1 here at the end. That's going to move me down 1. So my vertex from the origin will move left 2 and down 1. There's nothing in front here changing the shape of my graph. So to get the rest of my points count from the vertex, out 1 and up 1 on either side, and then out 2, up 1, 2, 3, 4. 1, 2, 3, 4. So we've moved left 2 and down 1. And then finally, for example 10, you've been given the graph here. Let's start by identifying our vertex. It's at -2, 4. So I know that this should look like x plus 2 squared plus 4. Since my graph opens upside down, I know my lead coefficient has to be negative. And then I want to check to see if I need to change that value there, if it's -1 or if it's -3 or what should it be. So to check that, I'm going to count from my vertex to the next nice point. I expect it to be out 1 and down 1 since we're negative here. And I land up on the graph for that. Let me check one more just to be sure. Out 2, down 1, 2, 3, 4 also lands me on the graph. So this would just be negative or -1 in front there. I don't need to stretch or compress at all. It would be negative x plus 2 squared plus 4. Questions for me on our graphs? Okay. Is this familiar? Yeah, should have been. Okay. So what we're going to do for the next couple of days is practice all those different skills that we looked at in our quadratics unit. So we worked on graphing here. The next thing that we'll take a look at are standard and vertex forms, sort of mirroring how we learned these in the first place. So we'll take a look at what we see in each of those forms, what they tell us about the graph, and how to swap between those forms. Then we'll take a look at factored form, what it tells us about the graph and how to get it. And then we'll do some practice with all these different function forms that we've got.